Welcome to all students in design of transmission system. Today we discuss about wear strength. Similar to wear strength of gear tooth, similar to the beam strength of the wear strength of the helical gear tooth can be found by replacing the helical gear pair by the virtual or imaginary spur gear in a plane perpendicular to the tooth element. So, in wear strength, to calculate wear strength, pair of helical gear is considered to be equivalent to a formative pinion and formative gear in a plane perpendicular to the tooth element. The wear strength of the spur gear is given by SW is equal to BQ dP dash K. Wear strength is the maximum value of the tangential force that the tooth can transmit without pitting failure. Therefore, SW is equal to BQ dP dash K. So, SW is equal to SWN is equal to wear strength perpendicular to the tooth element. B is equal to B cos psi, that is equal to face width along the tooth element. dP dash is equal to dP upon cos psi, that is equal to pitch circle diameter of the formative pinion. Therefore, SWN is equal to BQ dPk upon cos cube psi. So, the components of SW in the plane of rotation, it is donated by SW. Therefore, SW is equal to SWN cos psi. Therefore, SW is equal to BQ dPk cos square psi. From equation 18.4 is known as Buckingham's equation of wear strength. Equation 18.24 gives wear strength in the plane of rotation. Therefore, wear strength SW indicates the maximum tangential force that the tooth can transmit without pitting failure. It should be always more than the effective force between the meshing teeth. The virtual number of teeth on the pinion and gear are Zp and Zg respectively. The ratio factor Q for external helical gear is given by. The ratio factor Q for external helical gear is given by Q is equal to 2Zg dash upon Zg dash plus Zp dash. Substituting Zg dash is equal to Zg upon cos cube psi and Zp dash is equal to Zp cos cube psi. In equation D, we have Q is equal to 2Zg upon Zg plus Zp. Similarly, for a pair of internal helical gears, it can be proved that Q is equal to 2Zg upon Zg minus Zp, where Zg and Zp are the actual number of teeth on the gear and the pinion respectively. The pressure angle in a plane perpendicular to the tooth element is in the K factor. The K factor is given as K is equal to sigma c square sin alpha n cos alpha n 1 upon E1 plus 1 upon E2 upon 1.4, where sigma c is equal to surface endurance strength, it is given Newton per mm square. E1, E2 is equal to moduli of elasticity of material for pinion of gear, Newton per mm square. Alpha n is equal to normal pressure angle 20 degree. Therefore, K is equal to 0.16 Bhn by 100 bracket square. The above equation is applicable for steel gears with 20 degree normal pressure angle. In order to avoid failure of gear tooth due to pitting, SW greater than P effective, introducing a factor of safety, SW is equal to P effective into factor of safety. So, in problem, this is the problem of wear strength. A pair of parallel helical gear consists of 20 teeth pinion meshing with 100 teeth gear. The pinion rotates at 720 rpm. The normal pressure angle is 20 degree. While the helix angle is 25 degree, the face width is 40 mm and the normal module is 4 mm. The pinion as well as the gear is made up of steel 40C8. Ultimate tensile strength is equal to 600 Newton per mm square and heat treated to a surface hardness of 300 Bhn. The service factor and the factor of safety are 1.5 and 2 respectively. Assume that the velocity factor accounts for the dynamic load and calculate the power transmitting capacity of gears. This is NP is equal to 720 RPM, ZP is equal to 20, ZG is equal to 100, Mn is equal to 4 mm, B is equal to 40 mm, psi is equal to 25 degree, alpha n is equal to 20 degree. Ultimate tensile strength is equal to 600 Newton meter square, BHN equal to 300, CS is equal to 1.5 and factor of safety is equal to 2. So for this solving, first we calculate beam strength. Using this formula we calculate beam strength is equal to 26.87. After this we calculate Lewis factor Y is equal to 0.3475. After this bending stress we calculate by SU2 upon 3, that is 200. SB is equal to MNB sigma by, that is equal to 11120 Newton. K is equal to 0.16 into BHNN by 100 bracket square, that is equal to 1.44 Newton per mm square. SW is equal to BQ dP K upon cos square psi. Therefore, wear strength Q is equal to 2ZG upon ZG plus ZP, that is equal to 1.667. dP is equal to 88.27 mm. V is equal to pi dP NP upon 60 into 10 raised to 3. And CV is equal to 5.6 upon 5.6 plus root V. So 0.753. This is the CSW is equal to CSPT Fs upon CV. Putting this value, PT is equal to 2594.43 Newton. Then MT is equal to 114505.39 Newton per mm square. Newton mm. Kw is equal to 2 pi np upon mt, that is equal to 16 point upon 60 into 10 raised to 6. So after this calculating it is 8.63. This is assignment for homework. So complete this assignment at your home. This is the problem on design of gearbox hoist. Use AGMA approach. So solve this problem in gear home. This is gearbox design. It is cover, gear housing, flange, bearing, output shaft, input shaft, gear 3, shaft 2, shaft 3, gear 4, gear 5, input shaft. This is the gearbox design. So this is the reference book. So solve the assignment problem at home, and after this completed assignment, please check this assignment at college. Thank you all of you.